It is log 3 times 6, because we looked at a law of logarithm that says that when you're adding log of maybe, of course, we say here you don't see any base. You're not seeing any base, and we say that if the base is not there, then that means that you're operating in the base 10. There's a base 10 here. So numbers or logs to base 10, sometimes they may not write. Some of the logs base 10 they may not write. So they may not write the base there. So there's a silent base 10 here, there's a silent base 10 there. When you see any log and the base has not been indicated, just know you're dealing with a decimal base or base 10. So here you're having log to base 10 of 3 plus log to base 10 of 6. We said if you're adding, the law says if you have log of log of B base A plus log of C base A, as long as the bases are the same, what do you do to the B and C? You multiply the logs. You have log of A, B times C. That's what we do. Now, if they want us to express this as a single logarithm, all we do is we multiply 3 and 6. We shall have a single log, and this will be the same as 3 times 6, like that. And this becomes log of 18 in simple terms. We have expressed this log as a single logarithm. That's what we do there. Then next here, we can, what about this other one, the next one, Roman number 2, what do we do?
Divide.
Roman number 2, we divide. Roman number 2, we divide because we said when you're subtracting two logs, when you have log of B base A minus log of C base A, since you're subtracting, you divide the powers, so this will be the same as log of B out of C base A, like that. You divide them. You divide B and C. So here we shall have, this will be the same as log of 24 divided by 6. There's a silent base 10, even if you don't write it there, there's no problem. Somebody will just know you're dealing with base 10. So this will be equivalent to, the log of 24 by 6 gives us
4.
Gives us 4. So that will be log of 4. This becomes log of 4. Let me pick the pen again. Log of 4, like that. Then this are the next one. What do we do? Hello, mute yourself if you just joined in, so that you don't make noise. We have this half. Sorry? I repeat the first one. Hello, make sure you're muted. If you have no. So I repeat the first one. The first one I said that we are adding. This is log of 3 plus log of 6. And the law says when you're adding two logs, what happens to the 3 and 6? You multiply them. If you want to write them as a single log, you multiply them and you shall have log. This time around now it becomes log of 3 times 6. Since we're adding the two logs, we multiply the power 3 and 6. And this becomes 3 times 6 equals to log of 18. That's what we do. That's how we end. We end here. We can't proceed any further. If it was a log of 10, if they had given us 10, then we would have proceeded and said log of 10 to base 10 is 1. But now this one, you can't do anything. Number 2, we are subtracting. So what do we do the logs? We divide them. We divide the 24 and the 6. And this gives us log of 4, yeah, because 24 divided by 6 is 4. Then we on number 3. Number 3, we are saying log of 15 minus a half log of 9. What do we do there? Who can tell us what we do? Using the laws of logarithms, of course. Yes?
You take their half back to become, you take their half back to become the power of 9.
We take their half back to become the power of 9. So we shall have this a half moving back this way today to become the power of 9. We had that law where we said if you have log of, let's say, b base 8 power x, this x here can be carried the other side. And this becomes x log of b base a. That's what we say. So still we can carry the x back depending on what we're dealing with. I can still carry this x and bring it back this way. If it is here, I can bring it this way. If it is here, I can take it back. So these are half. Yes, we're subtracting. We're supposed to divide this, but we can't divide unless we've removed this half. So we shall have this giving us log of 15, of course, base 10 is silent, minus log of 9 power a half, like that. What does 9 power half, what does it mean? 9 power half means from our
Square root of 9.
The square root of 9. So minus log the square root of 9, like that. So this becomes log of 15 minus, this becomes log of 3, minus log of 3. Log of 3, because square root of 9 is 3. Then from here, since we're subtracting, you can now divide. This becomes log of 15 divided by 3, which gives me log of 5. And that's where I end. That's where I end. I've expressed it as a single. I've expressed it as a single logarithm, because the question wants us to express it as a single logarithm. That's what we've done. Any questions so far?
Excuse me, teacher.
Yes, please.
I've just joined. Can you please repeat?
Now, why do you come in late? 21 minutes. How shall we keep repeating up the end of the lesson? Another one is joining now. This is Beckham. So you just have to always keep time while joining. I'm going to share this video with you, and you get to know what we've looked at. But anyway, just a simple hint on what we've been doing. Just a simple hint. Number one, they said log of 3 plus log of 6. When they don't indicate the base, that means that you're dealing with a decimal base. It is base 10. That's what we said. You had that NB somewhere. And the law says when you're adding two logs, you multiply the powers. 3 and 6 have to be multiplied. So we shall have log of 3 plus log of 6 being the same as log of 3 times 6, because the question says express as a single logarithm. This becomes log of 18. Then another one is just entering what will not tell us to repeat. Then log of 24 minus log of 6. This becomes log of, since you're subtracting, you divide. You divide the powers 24 and that, so this gives us log of 4. And the number 3, when you join in, please mute yourself. Now, number 3, we had to first take away this half using this log here. We said if you are looking for log of b power x base a, you're free to take away this x and remain with x log of b base a. And you are free also to bring back the x. So at this point here, we're subtracting these two, but there's this half that we have to first remove. So I took away their half. We have log of 15 minus log of 9 power half. But from indices, we know power half means square root of that very number. So that becomes square root of 9, which is square root of 3. Now we're subtracting two logs. What do you do with the powers? You divide them. So this becomes log of 15 divided by 3, which becomes that log of 5. That's what we do. That's what we've just done. Are we together now?
Yes.
Okay. Next time you come early enough so that you don't have to waste time all the time. So Roman number 4, we have this. They are saying Roman number 4, we have 3 logarithm of 2 plus 2 logarithm of 5 minus log of 20. How do we handle this? They are mixing addition, we have subtraction. So what do we do here? We are supposed to apply the laws of logarithms here to express this as a single logarithm. So what we shall do is, the first thing we do before we apply the laws, we must remove these coefficients here, this and that. Here there is a silent one. So this one will come here, this one comes here. Here there is of course no coefficient. Okay, the coefficient is 1. So this becomes log of 2 power 3 plus log of 5 power 2 minus log of 20, like that. So this becomes log of 2 power 3 is 8. Log of 8 plus log of 25 minus log of 20. You see? So that's what we have. Then afterwards, we keep applying the laws. If I'm adding, what do I do? If I'm adding 2 logs, we just seen from the first example here that when you're adding, you have to multiply the numbers 8 and 25. So we shall have log of 8 times 25, like that. Log of 8 times 25 minus log of 20. I've combined the first 2. I've combined these ones here. These 2 here, I've combined them and have given me log of 8 times 25 minus log of 20. That's what we are. Any questions so far? Do you have any questions so far there before we proceed? Should we continue? So what is 8 times 25?
200.
200. So this will be log of 200 minus
100.
log of 20. What do we do next here?
We divide.
We divide, yes. So we shall have log of 200 divided by 20. So this becomes log of
10.
Log of 10, which gives us what?
1.
Which gives us 1, yes. Because you know this, there's a silent 10 here. Remember the definition of logarithm is simply saying if there's a silent 10 here, we're asking to which power should we raise this 10? So that is equivalent to that 10. It is just power 1. So that's what we have. That's how you answer this. And these are the possible question exams. You'll find such questions in ENEB, you know, in standard papers. If you check last week's New Vision, I put a question like this. So you'll find such questions there. Any question from this before we proceed? We want to proceed to another concept. We shall come back this later on at a later stage when you're learning how to solve now detailed questions. When they ask you to find the value of unknown, they can say log of x plus, let's say log of 8 equals to 1, and ask you to find the value of x. We shall look at these cases at a later stage. But as for now, let's just take what we have. Any questions?
Teacher?
Yes, please.
Could you explain why you changed it to 1 rather than leaving it at 10?
Why did I change it as 1? Why did I change it to 1 instead of leaving it as 10? You notice that in the previous examples, we've been leaving it the way it is. You're right to ask that question. Why is it that in the previous examples we left this as log of 5? Here we left it as a log of 4. but here we're saying it is 1. We're saying it is 1 because log of 10 to base 10 is known. Now here log of 4 to base 10, we don't know it. We don't know log of 4 to base 10. But log of 10 base 10 is 1. That's why you're writing the 1 there. We're changing it to 1 because there is another step forward that we can't stop here yet. It is possible for us to continue. You see? Here it is possible for us to continue the answer. We're saying if the base has not been indicated, then we're operating in base 10. Now we reach here and we have log of 10. Log of 10 to base 10 is known. It is 1. So that's why we proceeded to 1 to the answer 1. Yes,
Thank you,
Rodney?
teacher.
Yes, please. Rodney, your hand is up.
Excuse me, teacher.
Yes, please.
Like on number 3,
Roman
where we have got,
Mm.
yeah, show my number 3, where we have got log 5. Is it
Yes.
allowed if we use the calculator and find the answer and put it there? It's not allowed.
Now in this case, the question of this was saying, in this case, the question was saying, express each of the following as a single logarithm, you know, as a single logarithm. Now here you can't again go ahead and use a calculator. You can't use a calculator here. Here we went ahead to find the final answer because it is very obvious. The answer is obvious. That's why we went ahead and got the final answer as 1. But then log of 5 will require you to use your calculator, which has not been asked for. So expressing as a single logarithm, here you got log of 10 base 10, which is very obvious, and that's why we went to 1. Here you're not supposed to use a calculator, just leave it the way it is. Is that okay?
Thank you, teacher. Thank you, teacher.
You're welcome, please. Now we shall get back this in details when it comes to when you're now doing general revision at the end. But I think you have the concept and you can now open your question banks and try out a few questions. Now like this question I'll put here. These are the questions you find. Solve, look for the value of x. Solve for x here. Here, of course, you simply say log. You say log of, since you're adding this, it will be x times 8, which gives me 8x equals to 1. And here, of course, you have a silent base 10. We're simply saying 10 to power 1 should be equals 8x. So 10 to power 1 should be equivalent to 8x if you recall the definition of that we looked at during the introduction. So we're simply saying 10 to power 1 should be the same as 8x. That's what we're saying. Now, at this point here, you can now divide both sides by 8, divide by 8, divide by 8, and you'll find your value of x. These are the things we shall look at in details at a later stage. So my x becomes, of course, 10 by, I think 1.25, something like that. 1.25 or 0.25? I think 1.25, if you work it out. So that's what you do there. Now the next concept I want us to look at, we require the use of can you mute yourself? I'm hearing the echo here. So we require the use of mathematical tables. They are saying, here we're saying the logarithm of some numbers are integers, while logarithm of other numbers are not integers. Integers meaning, of course, integers you have this -1, -2, 1, 2, 3. These numbers here are what we call integers. They are not decimals like 1.2. This is not an integer, but these whole numbers are integers. So we're saying logarithm of some numbers can be integers, others are not integers. We have mathematical tables. There are mathematical tables which enable us to find the logarithm of these numbers. Now, like log of 10 base 10 is 1. That is an integer. Log of 100 will be 2. Log of 1000 will be 3 to base 10, of course. Those are whole numbers. Those are integers. But some of the logarithms, now like somebody said, you can use a calculator to find log of 5. This log of 5 will not be an integer. Can somebody get for us this log of 5? For those with calculators, get us a logarithm of 5 and we'll see what will give us. Of course, it's to base 10.
0.6987.
0.6.
0.69897.
97, you see? Now this is not an integer. This,
0.69897004.
it is like this. So this is not an integer.
0.70.
This is not an integer. So some values will give us integers, some will not give us. So
0.69870004.
okay, so here what we're going to do, let's now pay attention. We are going to use our calculators to find these logarithms, then also go to the mathematical tables and find the same logarithm. We're going to compare those two sets of answers and we see whether they are really the same. So let me create space here. Annotating. We want to look for log of 1.86. The way we find this logarithm differs. The way we find the log of a number between a number between 1 and 0 is different from the way we find the log of a number between 0 and 1, and also for numbers above 10. We're going to look at those different ways of finding logarithms. First of all, finding log of numbers between 1 and 10. That's the first thing we're going to look at. Then the next one, logarithm of numbers greater than 10. Then next, we'll look at logarithm of numbers between 0 and 1. Those three stages are what we're going to look at. How do you find log of a number between 1 and 10, above 10, between 0 and 1? That's what we're going to do. But the most important thing is you knowing how to find the logarithm of a number between 1 and 10. Then from there, we shall use that knowledge in finding other logarithms. Okay. So our mathematical table that we're going to use, can only give us logarithm of numbers between 1 and 10. Between 1 and 10. So if you're looking for a logarithm, for the logarithm of a number above 10, then you'll have to first express it in standard form and bring it to logarithm of a number between 1 and 10. If it is less than 1, you'll have again to write it in standard form to bring it in this range of numbers between 1 and 10 before we find the logarithm. So let's start with what we have here. Find the logarithm to base 10 of the following numbers. Our calculators can only give us logarithm to base 10, not in another logarithm, in another base. All our calculators and all the mathematical tables that we're going to use can only give us logarithms of bases, of base 10, logarithm to base 10. Outside that base, then we shall look for other methods. But then tables, calculators will give us only logarithms to base 10. Now let's look at this. Find the logarithm to base 10 of the following numbers. Can somebody give me the answer of this from the calculator? Log of 1.86.
0.27.
27.
Are there
That's
other
if I round
values?
it off.
Give
Okay,
me
0.26951.
Give me to 4 decimal places.
0.2695.
0.2. What is this? 0.2697. Okay. The pad is also not being sensitive. So that's what we have, 0.2697. Now we want to go and look. Yes?
5.
Sorry?
0.2695.
Okay, let me first clear this.
5.
The log of logarithm of 1.86 to base 10. We're finding it as 0.26995. This is what we have. Now I want us to go to, okay, we wanted the 4 DPs. This is just enough. Now let's go to the log tables and we see how we can use logarithm tables to find these logarithm. Are you seeing this table? Is it clear?
Not yet. Not yet.
Hey,
Now it's clear.
Are we seeing that table?
We're talking about that. Eh.
Do you have this logarithm table?
Yes. In some girls' textbook.
What is an online one, I think?
So now here, we want to find the logarithm of, let me pick a pen here. Oh gosh, what is this? It's taking some time to come. So how do we find 1.8? Is it logarithm 1.86? We want to find log of 1.86. Let me choose green. I think green will work. Okay. Quickness, I increase it slightly. Okay. So the log of now I see. Okay, it has come. It has again disappeared. Log of the pen has again disappeared. Okay, let me write here. I'll make sure I make it bigger, smaller. I shift this slightly to this point. Okay. Now we want to find log of 1 point. This is too thick. Let me reduce on the thickness and get a clear color. I think blue will work. Okay. Log of logarithm of 1.86. Now this mathematical table you're seeing here, the logarithm base, the base is base 10 always. So all the values you're going to get from here are only for log to base 10, not any other base. So we're saying, and the number has to be between 1 and 10. Now what if they want to find log of 25? How do you find it from this table? We shall look at that at a later stage. If they want to find log of 0.25, how do you find? Because 0.25 is outside this range. The range they are talking about here, it must be 1 and 10. How can you use this table to find the logarithm of 0.25? Somebody is asking something? Thank you for the class. I'm just checking. It's okay. Need to see. So, how do you find the log of the log of a number between 1 and 10? So here what we shall do, we have 1.86. Now our first two digits, 1.8, are found in this column here. You look at this column headed X, it will give you always the first two digits. So I come to this column and look for 1.8. Have you seen 1.8? Have we all seen where 1.8 is?
Yes, sir.
Yeah, so in this column, my 1.8 is here. You see it? So then the third digit is 6. My third digit is 6. The third digit is found from here. Third digit is found from the first column. I mean, this is first row, not column. Then here, this column has the first two digits. 2 digits are found from here. So the first 2 digits are obtained from here. Then the third digit is obtained from this side. Now I have 1.8. I've obtained it somewhere here. I don't have a highlighter this side. So, but it is here. I've circled it. Have you seen where I've circled 1.8?
Well said.
Yes,
Then
sir.
I look
Yes.
for 6. Where is 6? 6, which is my third digit, is obtained from here. This column here gives me the third digit. Up to this point, that's why I get the third digit. So my third digit is 6. So 6 is somewhere here. Now the next step, what I'm going to do, I look for the intersection. Let me choose another color. Which color it will be? I think yellow will work. Now I look for the intersection. I see this one is coming like this. Then this one comes like that. You see? The value I'm looking for is this one here. You see it? Now all these values you see, there's a decimal place before them. That's, you see now like here is 0 point, there's a decimal point. That means there's a 0 in front here. There's a 0 in front here. There's a 0 in front. So even here, there's a 0 point, that value. So that means that my logarithm of 1.86 will be equivalent to 1. What are we seeing here? 0 point. Can somebody read for me that value?
0.2695.
2695. Isn't it the same as the value you got the other side?
Yes, teacher.
It is the same, yes. It is the same. Desmond, you have your hand up? Yes, Desmond? Desmond, we are waiting for your question or any suggestion. You have your hand up. Desmond? Please only raise up your hand if you have something to say so that you don't draw our attention and then you just keep quiet. So you put up your hand when you have something that you want to maybe talk about. Yeah, so back to the words. So you notice that even in the table, we found the same value. We found the same value using the table. Now let's go ahead. I'm just going to open the table and you read for me the values for these logarithms here. Very fast and we proceed. Let me create space here. I'm just going to open. Now don't use the calculator when you're using, when they say use, you notice that our values from the table, all of them are to 4 decimal places. Some of you use calculators and write your answers to 3, to 2, to 1, and that's when they will know that you've not used the method. The question will always say, use mathematical tables. Then for you, go ahead and use calculators, and that's how they will know that you failed when you write to different decimal places. Okay, we go back to the table and you give me the logarithm of 2.356. Now, when you have 4 digits, what do you do?
Round off to 3 decimal places.
Let's first go to
You add the last digit on the value.
Now you see on this other side they are saying add. They are saying add. Now what if we had another digit this way? What do we do? How do we treat that digit? Let's go to the next example and to tell us what to do there. So in this case, you're finding the log of 2.356. Can you use your calculator and you tell me what this one is so that we just go to the site to confirm? What does the calculator say? Yes, Mugaga?
Teacher, I have a question.
Yes, please.
Now, when we have those logarithm tables, and we take them to school, are we allowed to take them to the examination?
Yeah, they even give you in NEP, they'll give you those tables. You'll have to give you the tables. So that's okay.
0.3722.
Let's be organized. One person, can somebody put up the hand so that we have an organized video lesson? Can somebody? Yes, we are hunger. It is
0.3722.
0.3722. Okay, the pen is misbehaving. 0.7322. So that's what we have. Let's go to the math tables and see whether we shall get the same answer. Mathematical tables. We're finding the log of, I've forgotten, what is it? We're finding the log of what? I've forgotten the value already.
2.356.
2.356. So I come to 2.356. That's the log. We're looking for the logarithm of that. So where is 2.356? We say the first two digits are found in the column headed X. This is the column headed X, is X here. So 2.3, I first look for 2.3, it will be here. This is my 2.3. Then the third digit is 5. Third digit, I get it along this to 5 is here. So I look for the intersection of the two. This one, like that, up to here. Then this one, but when you're using your math tables, don't write in them the one I'm writing in mine. For me, mine is, I can always change. It's a soft copy. I can even delete. So when you write in yours like this to reach a time, they won't even allow you to enter with it in exams when it is written, when you've written in it. So let me choose another color here. I choose possibly blue. So 5, 5, 5 is here. So this is what we have. We have 3, 7, 1, 1. That's what we have. 3, 7, 1, 1. Now we've not put a decimal point because there's another digit. We're still reading our values before we introduce a decimal point. Now what's the other digit? The other digit is 6. This 6. Now you see this on the extreme right, there's something called add. We have to add something, and we're adding something related to 6. 6 is here. I also bring this one down. Make sure I bring this one horizontally up to 8. I'm again canceling something. Up to here. You see, they are coinciding at this point. 6 coincides with 11. So I come here and add. I add, because the column says add, I add 11. And this gives me 3, 7, 2, 2, like that. So that means that the log of logarithm of 2.356 will be equivalent to 0.3722. Isn't it the same?
Oh, everything is 0.0.
Teacher, it's the
They're the
same.
same. No, no, they're the same.
Sorry? You have a
They're the
question?
same.
Teacher, it's
They're
the
the same.
same.
Yeah, it's the same.
Teacher, they're the same.
The same. So that's how we do that. What about 9.991?
0.9996.
0.996.
996.
We want 4 decimal places.
0.996. The last one is 6.
How many 9? It is 6 here.
Yes.
Okay. So we go to our table and see whether that is correct. We're looking for the log of 9.991. The first two digits are obtained from the first column. So I look for the 99999999. 99999. It is almost 10. 99. 99 is here. The next one is also 9. Oh, but it's now very far. Okay, we can use, I think it is here. Okay. We're looking for the log of 9.991. What will this be equivalent to? So I've gotten the first two digits from here as 9.99. Then the third one is here. I look for where they coincide, the coincidence of the two. They coincide. Now I'll keep on scrolling. Right? Let me just make the table smaller, but I don't over scroll. 9. I come to 9. Make it smaller again. Smaller. When I look at that 9, it is somewhere here. So that gives me, 9999996 gives me 996. So what I've seen so far is 9996. Then where is the 1? 1 is here. 1 is there's a 0. It consists a 0. So I add 0 to that. That means that my log, I can now zoom. It's zooming in or zooming out? Zooming in, like that. So this becomes plus, I add 0 to this, and this becomes, my log becomes 0.9996. This is what we got from the other side. Do you have any questions? Any questions from what we looked at so far?
Yes, teacher.
Yes, please.
I've just joined and I am not understanding what's going on.
How do you find the stuff using a calculator?
Sorry?
How do you find the log using a calculator?
Your calculator's log. Just put log on
How do you find
question.
How do you find it?
Log and what? I put log and what?
There's a button
Just
which
press log
There's
and then put the question there.
log, and then you put the question, that number which you see.
Yeah, you show them using that.
Then you press
Thanks. Thanks.
Okay, you see the button for logarithm on your calculator?
Yes.
Yeah, just type, you press log and even the number that you have. Now like 99, you just put the 9.991 and will give you what you're looking for, the logarithm that you want. Okay. So next, I think you can now finish up the rest. We've understood how to use the tables to find our logarithm. You can now finish up the one for 3.180, that. But then if there are if it is to more than 2 decimal places, if it is to 3 decimal places, then what you do, you have to add. But then adding, you add before you introduce a decimal point. Now, if some of you, the mistake you make, you first introduce a decimal point, then add 1. That will give me wrong. It will give you a wrong answer. Let me show you what I'm trying to talk about here. For instance, I got this 9.996. Then I added 0. This is okay. Let me go to maybe the other one to make more sense. So I added something. Now look at this. We have 377. I mean 311. 311. I mean 3711. And we say you first add 11 before you introduce a decimal point. Now some of you have, if you first put a decimal point and say this is 0.3711, then you add 11. This will give you 11.3711, which is very wrong. So what you do here is you first add before you introduce a decimal point. Introduce a decimal point. That's when you get the correct answer. Hello, can you mute yourself? Mute yourself. Let me go back to the work. Now you do this, you do this one, you do that one. That's all you've been looking at, and I'm sure you can handle. I want to look at, there's a question I put here, this last one. What about this 7? How do you find the log of 7? Use your calculator and give me the log of 7. It will be the same as
0.8450.
0.8451.
1. That's what we have, 8451.
Yes.
Now, when I want to use my table to find the log of 7, what do I do? 7 is the same as, because this table can give us values to 3 DPs, maximum 3 DPs, 3 decimal places. Is it 3? 1.0, third, fourth, to 4 DPs. If your number is to 4 DPs, you can find that logarithm. Now like 9.991, 9.991, maximum 3 DPs. Now what if you have 7? How do you find the log of 7? Because here we have values to 2 DPs. So this 7 is the same as 7.0. The same as 7.0. So I'll just come to 7.0, it is here. We're looking for 7.0. 7.0, I just add 1 dp and become 7.0. 7.0 is here. Now, how do I get the next value? I also add another 0 because there are no digits before that. So I add another 0 here, like that. This becomes 7.00. And that means that when I'm looking for the third digit, it will be the 0 here that I'm going to use. So I come down and look for where 0 is. This will be the value, 0.8, 0.8451 is 0.8. So the log of that is 0.8451, like that. If you add another 0, then that makes the section of add, but you don't have 0 in the section of adding. So that's why you stop. So that means if it is 7, you just add 7.00. Then you come and look for the logarithm. If it is a whole number, that's how we find the logarithm of a whole number. You simply add extra 2 zeros, then come and look for it just like any other number. That's the special, that's the special case of 7.
I beg your pardon.
If you're looking for the log of 7 or any other whole number, we notice that our tables can give us logs of numbers to 3 decimal places. Let me go and write in the table itself. This one can give us logarithm of numbers that are in these 3 decimal. You can see this one. Log of 9.991. We came here, looked for 9.9. Then Luke came and got the 9. Then came here and got the 1. So these are 3 DPs. Each number means something in terms of getting the logarithm. These 2 digits, we get them from the first column. The third digit, we get it from the first row, which is this. Then the fourth digit, the fourth digit, we get it from the section of adding. That's how we get it. Now, what if you have just 7? Just 7. This 7, you have only the first digit. Where's the second digit? Where's the third digit? Where's the fourth digit? So we say, if you have something like this, then add other 2 digits, 00. Just 7 is the same as 7.00. So therefore, I'll come to my first column, get my first 2 digits, which will be 7.0. I'll get it here. Then come to the first row, and I look for 0. 0 will be here, and that will give me the log of 7, which is the same as 7.00. And of course, adding with this, you don't add anything because in this section, you don't have 0. In the section of adding, there is no 0. So we just add 2 extra zeros. If they say find log of 8, I'll say this is the same as 8.00, then I come and find. If they say find log of 6, I'll say this 6 is the same as 6.00, then I come and find it. Is my point clear now?
Yes.
Yes.
Okay. Rodney, your hand is up.
Yes, sir.
Rodney, I see your hand up.
Excuse me, teacher.
Yes, please.
Can they give us a number with more than 3 decimal places?
With more than?
Can they give us a number with more than 3 decimal places?
Yeah, they can. And I have another example. The next example here is talking about that. Of course, this one you can now find. Now, this one here, you see that it is having more than 3 decimal places. So in such cases, where you have numbers to more than 3 decimal places, you have to round off. You round off. The pen is misbehaving, you have to bear with. You round off. The pen is misbehaving a bit. We shall have to bear with it. So when it is to more than 3 decimal places, just round off, then you find the logarithm. Before you find the logarithm, because the table will not give you logs of numbers that have more than 3 decimal places. So this will be the same as 1.834 3, 5 when you round off. 3, 5. This is to 3, 3 decimal places. Yeah. So this one can now be formed. I think you've noted that. Whenever you have more than 3 decimal places, round off to 3 decimal places before you proceed. Do you have any questions from this section? Hello?
Yes.
Yes, please. What's the question?
Not understanding how to use the logarithm book.
You're not understanding how to use the logarithm book?
Yes.
That's now the disadvantage of coming in late. When you come in late, it will always take us time again to review the same things. But if you come early, because the link is sent early enough, make sure you set up yourself early enough and come for the lesson in time. But now if you keep coming in late, your friends are moving forward, and you keep going back, you know, you waste a lot of time on some small things that we would have covered early and moved on. So just to make you catch up with us, if you're finding log of 9.991, we said this table can only be used to find logs of values that are between 1 and 10. Between 1 and 10. You notice that 9.99 is between 1 and 10. We can't find logs of values that are beyond 10 or less than 1 using this table. We cannot. So if you'd find log of 9.991, there's this part-headed x. This part-headed x gives you the first 2 digits of the number whose logarithm you're finding. The first 2 digits are found from this first column here that goes down. Then this horizontal one gives you the 3rd digit. The 3rd digit is obtained from this row here. Gives you the 3rd digit. Then this section of adding is for the 4th digit. Now, any number written to 3 decimal places, of course, we shall be having 3 digits. If you have a number written to 3 digits, we shall be having 4 digits, So 9.991, the first 2 digits are 9.9. I'll come to the first column here and look for where 9.9 is. You'll move down and find your 9.9. Your 9.9 is here. This is 9.9. I've obtained it from the first column. Then the next digit is also 9. The next digit is 9. Where is the next digit? 9. Next digit is 9, which is the 3rd digit. 3rd digit is obtained from here. My 3rd digit is 9, which is this. So after that, I look for where the 2 coincide. Where do they meet? The line from this other 9. And I draw this line downwards like this. Downwards like that. You notice that this one, when it comes down like this, it meets this other one at this point. That's where they intersect. So that means that my first 2 digits, my first 3 digits, my first 3 digits are giving me that value. They are meeting at 9996. That's what they're meeting. Then I look at the next digit. What's the next digit? The next digit is 1. And the next digit, I get it from the section of adding. Next digit is here, 1. What does this 1, which value does it represent here? Where they meet? 1 has a 0. But since the information here says add, you'll find sometimes tables which say subtract. But of course, the ones you will be using in exams, always, they'll have add. So when they say add, I come here to the value I got at first, I add it there as 0. And when I add 0, it still remains 9.991. But all these values you see have a decimal point between them. All these values from here, like this, up, down ones. You see that the first one, that is, they try to put for a decimal point, meaning that there's a 0 before. There's a decimal point here, there's a decimal point here, there's a decimal, that means there's a 0 before. Even these ones are the decimal point, but they didn't, to economize space, they stopped putting decimal points in this column here. So what we do, that means that the log of 9.991 is equivalent to 0 point. Now the value you obtained, 999, like that. Are we together now?
Yes, teacher. Thank you.
You're welcome. But keep time next time. Next is want to look at how to find logarithms of numbers greater than 10. If they say find the logarithm of 11, logarithm of 12, we know logarithm of 10 itself is 1, of course, we know that one. Logarithm of 10 itself, logarithm of 10 is 1. Now, if they say logarithm of 11, how do you find it? Logarithm of 12, logarithm of 30, 50, 100, 1000. How do you get those logarithms? We're saying, if you can read this, this statement here. Pius, you read for us this. What does it say?
Yes, sir.
You read for us this statement, this one here, just below logarithms. It says,
Numbers that are greater than 10 are first expressed in standard form in order to get their logarithms. That is a times 10 power n, where 1 is less than a and a is less than 10. And then the laws of indices are applied.
okay, all right, thanks. So we're saying, if you're finding logarithms, for you to find the logarithm of numbers greater than 10, you have to first express those numbers in standard form. And of course, let's first have some simple question here. What is 1.5 in standard form? 1.5 in standard form will be the same as
1.5 times 10 to the power 2. 1.25 times 10 to the power 2.
Times 10 to the power 2. Yeah, so that's what we're saying. 1.25 times 10 to the power 2. That is 125 in standard form. Now you notice that this 1.25 is between 1 and 10, and our math tables can give us logarithm of numbers between 1 and 10. So that's what we're saying. If you have a number greater than 10, first express it in standard form, then afterwards, you go and look for its logarithm. You look for the logarithm of a. This one can be found. Remember, we're saying, I will first have to remind you of the law of logarithms. If you're finding logarithm, I don't know why this pen is misbehaving. Logarithm of 7 base 10, we are saying this is equivalent to 0.8451. And the way we define logarithms, we're simply saying 10 to the power of 0.8451 is equivalent to 7. That's what we're saying, and that's how we define our logarithm. If you recall what we looked at in our very first class. This one can also be written as 10 to the power of 0.8451 is equivalent to 7. That's what we're saying. Even here, when you find log, the one we're finding this side, even here, what we're doing, the log of logarithm, the pen logarithm of 2.3 5, 6, the base 10, we say it is equivalent to 0.3722, like that. That's what we said. Here, still we're simply saying 10 to the power of this must give us that. If you have a calculator, you try to prove it. This is the same as saying 10 to the power of 0.3722 equals to 2.356. That's what we're simply saying. That's what we're simply saying. So this is 6. That's what we're simply saying. So even here, if they want you to find the log of 125, what do? First express 125, because you know that our tables don't have values beyond 120, above 10. It has values between 1 and 10. So what we do is we first express this in standard form. What we're trying to do is to bring it to a number that is between 1 and 10. And that is now 1.25. I can now go to my table and find log of 1.25. So when I find the log of 1.25, what do I do next? Remember, log of 1.25, so let's go to the table and look for 1.25 so that we come back and talk about things we are seeing. Let me go to the table. Unfortunately, this cannot allow me to write this side. Admit. Now, what's the log of 1.25? Let's get it from this table. 1.25, log of 1.25, 1.25, 1.2 is here, and 5 is here. 1.2 is here, and 5 is here. So the log of 1.25 is 0.0969. We have nothing to add because there's no, the next digit is not there, the fourth digit is not there. We have only 3 digits. So 1.25, the log of 1.25 is 0.0969. Is 0.0969. So when I come back here, let me create space. This is just like an illustration before we proceed. So we're saying that log, the logarithm of 1.25 is equivalent to 0.0969. That's what we're saying. This is base 10. That means that my 1.25 is equivalent to 10 to the power of 0.0969. That's what we're saying. Now here where we're saying that 125, the pen is also missing, 125 is equivalent to 1.25 times 10 to the power of 2, isn't it? But then we've just gotten from logarithms that 1.25 is actually the same as this, the same as all of that. So there is one, where there is 1.25, I'm going to remove and replace it with that. That means that my 125 will be equivalent to 1.25, which is the same as 10 to the power of 0.0969 times 10 squared. Are we together up that point?
We're there.
Yes, sir.
Yes, teacher.
Okay. Now, because we're trying to make sense of this statement here, they say numbers. Yes, Rodney, your hand is up. Rodney? We are listening, waiting for your question because we don't want to move on when somebody has issues. Yes, please.
It was by mistake.
Okay,
It was by mistake.
Okay, it's okay. Now, where's my pen? We continue. Now here, we're saying numbers that are greater than 10 are first expressed in standard form to get their logarithm. I think you've now known why we express in standard form. We want to reduce the number so that we write it between 1 and 10. And that's what we've done. The next thing is those who are moving up and down, going in, going out, make sure you settle because this we're going to apply this in the next lesson. So make sure you understand. And this question is very popular also. Questions that require this. I'm building it up so that we don't have issues with it. Now we're saying that is a times 10 power n, which we've done here. That's like 1.25 times 10 power 2, where a is between 1 and 10, which is this, and then the laws of indices are applied. Now I want to apply the laws of indices here. When you're multiplying two numbers of the same base, what do we do in indices? Same base, we add the index. So that means that 1, 2, 5 will be equivalent to 10 to the power of 0.0969 plus 2, like that. Plus 2 like that. And this will give us what? This will give us 10 to the power of 2.0969. So therefore we can conclude and say 125 is equivalent to 10 to the power of 2.0969. This is in index form. How can I write this in logarithm form? Can somebody tell me how to write this in logarithm form? We're winding up. We have around 10 minutes to the end of the lesson. How do you write this in logarithm form? This in index form? Hangs, Matthew?
Log 125 to the base 10 is equal to 2.0969.
Perfect. Yeah? That's very okay. So log of 125 to the base 10 at the base of 10 is equivalent to 2.0969. As simple as that. So that's how we find log of 125 for numbers that are greater than 10. That's how we find their logarithms. You first write it in standard form. After writing in standard form, you find the log of this other number, then just come and add to 2. So later on, after practicing, you may not go through all this process. I will simply write it in standard form, then the next thing I write 2 point, I get the log of this, I write it there. Let me now show you how we can do the next one, these examples. I'm doing only one example. We shall do the others in the next lesson because our time is almost up. Any questions so far before we proceed? So they want me to find log of 27.4. This is above 10. What do I do? The first thing is I express this in standard form. I write it in standard form. And this will be equivalent to 27.4. What is this in standard form? Can someone tell us how this will be in standard form?
2.74 times 10 to the power 1.
2.74 times 10 to the power of 1, like that. Then this one is between, this one is between 1 and 10. So this will be the same as 10 to the power of, I need to find what the log of this is. The log of 2.74 is equivalent to what? I go to my tables and look for log of 2.74. 2.7 is here, and 4 is 2.4 is here. That would be 0.4378. That would be 0.4378. 0.4378. 0.4378. That's what I have. That means that I can also say that 2.74 is equivalent to 10 to the power of 0.4378, like that. So I come here and say 2.474 is the same as this, so it is the same as 10. That will be 0.4378 times, now this 10 power 1, 10 power 1, like that. So this will be the same as 10. I just add the powers. This will be 10. I add the powers, this plus that gives me 1.4378. That's what I do, and my answer will be the same as what? That means that the log of 27.4 of 27.4, the pen is misbehaving, will be equivalent to 1.4378. That's how I do it. Have you understood now? Hello?
Yeah.
Okay.
Yes, teacher. Yeah.
So let's do one last example here. This time around, I'm not going to show all that. I'm just going to show you now the shortest way of doing all that. The shortest way of doing this, I'll simply insert a table. I insert a table, and this table will be having 3, like this. Where is my table? That has gone very far. I can bring it back. Now this table, I've put what is that? I'm again deleting my things. Let me, I've deleted almost everything. Let me undo. Undo again. So in this table, I'll have 3 columns. The first column will have my number, or the number which I can even call X. Then the second column, I put standard form. Standard, that's standard, yes, standard form. Then in the last column, I put the logarithm. Like that. Now in the second row, in my second row, I'm going to put now the number. What's the number whose logarithm I'm looking for? Since I've deleted the other one, do you recall what it was? I doubt. Let me just see.
8.34.
Let me, is it in view? I'll get the pen. Let me first get my pen. Is it in view? Is it in the review? Yes, it is here. So I can, yes, just come. Now my number, the number we have forgotten it, but let me just write 2. Let me write the one we've just been dealing with, 27.4. This is my number, 27.4. Now I'll come here in standard form. We say 27.4 is the same as 2.74 like that times 10 to the power of times 10 to the power of 1 like that. Now when I come to the side of logarithm, I know obviously that this one will always come here, then I add the other one. Notice that in the first example, we're just adding whichever log I'll find from this side, I'll add it to the power that I have, I'll add it to 1. Even in the first example that I gave you here, this example here, where is it running out? This one. Here we found the power of 2, and we added these 2 to whichever power we got from this side. We added 0.0969. So here also what I'll do, since it has become obvious that this power will always be added to what I'll get this side, I'll simply say 1, I put this 1 point, then I go to my table. What do I get from the table? I get 4378. I just come and write it here, 4378. Like that, I'll have my logarithm already. Even for this one, now let me demonstrate that.
I beg your pardon.
You want, okay, I'm going to pardon. I'm saying, if you're looking for the log of 27.4, the first thing you should do is write it in standard form, and that's what we shall have something like this in standard form. It is 2.74 times 10 power 1. But then from here, what we've realized is that when I write it in standard form, I'm going to get the log of this and write it also in index form like this. Then the index I get here, the log of 2.74 is what I add to 1 to get 1.4378. So without wasting time, I may just have a table like this and write my number is 27.4. Standard form is 2.74 times 10 power 1. Then I just drop this 1 because I know this 1 in the logarithm. In my final answer, this 1 is here. I got it by getting 1 plus 0.4378 like that. That's how I got some noise. Yes. So that's how I got this value here. I simply got the power of 10 plus the power of 10 here, which means this is the log of 10. Log of 10 is 1 plus the log of 2.74, which is the same as 0.4378. Now here we just want to save time. Instead of writing them in power index form like this, then we come to this, then we come to that, then we come to the answer. Finally, we can simply have a simple table, and in our table we have the number, standard form. Now this power here simply drops, it comes here, and then I look for the log of this and put a decimal point. I write that log after the decimal point. Let me explain that more using the next example here. Maybe it will make more sense when we look at this. Another number. So I'm looking for the log of 3,821. So I'm saying you can have a table. Let me just see. Let me just copy this table. My table is control copy. I'll come here and paste it. Control V. So from this table, I'm going to delete what is inside. Then we'll have another number. I just remove this, I remove that, I remove that. Now, in this case, we have the number whose logarithm we're looking for is 3,821. That's the number whose logarithm we're looking for. There's no decimal point here. Now, a moment. What is this number in standard form? Can somebody tell me how we write this in standard form? It will be the same as
3.821 times 10 to the power 3.
3.821 times 10
to
the power of 3. Now, just like here, we realize that our last log was supposed to add this to the log of 2.74. Even in the other example, this other example here, we had to add 2. We were supposed to add 2 to the log of 1.25. I think you noticed that. And our answer was 2 point. Now this is the index of 10, which is that. And this is the log of 1.25. Even here, you notice that this one is the power of 10, and this is the log of 2.74. Now, even here, since we've known that from the previous examples, instead of wasting time, I'll simply say this will be 3 point, then I look for the log of 3.821. What will it be equivalent to?
5822.
What do you get?
5822.
5 point?
3.5822.
5822. Now here we're not using the calculator. We simply dropped the 3, then we went to the tables to look for the log of 3.821. What is the log of 3.821? I go to the table. 3.821. 3.821. 3.8 is here. 2 is here. Let me reduce it so that we see everything. Now 3.8 is here. 2 is here. They are coinciding on this value. I think that's where they're coinciding at this value here. 5821. But we're looking for the 3.821. 2 is here with 1. In the add section, 1 has 1. 1 has 1. So I add this 1 to this will be 5822. 5822. So the other side I've written 3 already, 3 point. So I simply say this is 3.5822, like that. And that's how you find the log of that. And the same applies to these other ones. Write it in standard form and then go ahead and look for. Even this one, you do the same thing. Log of 10. Log of 10, if you're looking for the log of 10, of course, you also have a table. Let me paste it here. Control V. The table comes. I delete out these other ones. Now you're looking for the log. Our number, the number whose log we're looking for is 10. Standard form, how do you write 10 in standard form? That would be 1.0 times 10 times 10 to the power 1. Now here I just write 1 point. 1 point, I go and look for the log of 1 from my table. What's the log of 1.0? Log of 1.0, 1.0 is here, and since there are no other digits, I'll say 1.00. It will be that. It will be 0, 0, 0. There are 4 zeros. So I just come here and say my log of 10 is my log of 10 is 1.0000, like that. So that's how we find logs. Even 1,000, you do it the same way. 1,000, you're simply going to create, this is the last one you're looking at. The others, we shall look at them later, after the break. I'll paste the table here. Then I delete a few things. Delete this. You're looking for the log of 1,000. Log of 1,000, I'll simply say the number whose log I'm looking for is 1,000. That's the number whose logarithm I'm looking for. Standard form, 1.0 times 1.000. There are 3 zeros. 1.000 times 10, the power of 3. What do I do here? I simply drop 3 point. What's the log of 1.00? We just found it as 0.0000, like that. So that's how I find the log of logarithm of 1,000 is 3.000. Logarithm of 10 is 1.9. Have you understood?
Yes, sir.
Yes, sir.
Okay, so that marks the end of today's lesson. Thanks for attending. I'm going to share this video with you on my YouTube channel. Go there and copy the work. I'm also going to share the last week's lesson and even this one, so that after the break, you should have copied all this work up to where we've ended. And after that, we shall build on that to go and look at the logarithm of numbers between 0 and 1. And also look, after that, we go now and look at anti-logarithm. How, if they give you a logarithm and ask you to look for the number, how do you get it? That's what we shall look at next time. Maybe if you have some questions, you have suggestions, any inputs, is there anything somebody wants to say?
Thank you, teacher, for